Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Let me know quickly in the chats if all of you can hear me, if I am perfectly audible and visible to every single guy. Let me know quickly in the chats with some thumbs ups. Quickly people, everybody. Good evening and welcome back. Good evening and welcome back. Good evening and welcome back, people. So quickly, let me know in the chats if all of you can hear me properly, if I'm perfectly audible, visible to everyone. Just give me a second, let me fix certain things and we shall start. All right, people. I think I'm perfectly audible, visible. I feel I'm perfectly audible, visible. Yeah? Perfect, guys. Perfect. Someone is saying take the next chapter as solution. Surely, why not? Perfect. So people, are you done with the electrochemistry? Have you watched the marathon which I posted of this particular chapter, like I think a month before? Are you done with that? Are you done with that marathon? Say yes or no in the chats, quick. Are you done with that marathon? Perfect, guys. Perfect, perfect, perfect. So today we are going to do the questions of the chapter Electrochemistry. Whatever types of the questions can be asked from the chapter Electrochemistry, I have come up with all the patterns of the questions. Be it the questions from your NCERT in-text, NCERT exercise, your NEET PYQs, JEE Mains PYQs, every single type of question is included in the today's session, right? And I believe if you have watched the electrochemistry marathon, which I took like a month before, you should be in a position to solve each and every question of electrochemistry on your own. Yeah? If you have watched the marathon properly of the chapter Electrochemistry, my dear students, you should be in a position to solve each and every single question on your own, right? So, I'm sure you guys are ready with your pen and paper. So let's get started then. Without wasting a lot of time, let's get going. Let's get started with the first question, my dear students, which is on your screen. Look at the question, exactly what is to be calculated in the question. The question is your NCERT example, right? So it is the NCERT in-text question. It is the NCERT in-text question. Represent the cell in which the following reaction takes place. Calculate E cell if E naught cell is 3.17 volts. A very simple and basic question, right? So first of all, we are supposed to represent this particular cell. My dear students, how do we exactly represent a cell? You should know it by now. We have discussed all of this in detail. First thing, at the middle, I'll be drawing two lines which represent your salt bridge. And on the left side of the salt bridge, we always write anode. On the right side of the salt bridge, we always write cathode, right? That is something which we do all the time. Now, if you look at this particular reaction, what is the oxidation state of magnesium here? It is 0. What is the oxidation state of silver here? It's +1. What is the oxidation state of magnesium here? It's +2. What is the oxidation state of silver here? It is 0, right? If you look carefully, what is happening to the oxidation state of magnesium from 0 to +2? Oxidation state of magnesium is increasing, right? And you should know, increase in the oxidation state of an element is something which we call as oxidation. So I would say magnesium is undergoing oxidation over here, right? And oxidation takes place at anode. On the left side, we write the anode. So at anode, we got to know your magnesium solid is getting converted into what? Is getting converted into Mg di-positive aqueous. It is getting converted into Mg di-positive aqueous, right? Similarly, on the right side, we'll be writing the cathode. At cathode, reduction takes place. Say, silver is changing its oxidation state from +1 to 0. So decrease in the oxidation state. Decrease in the oxidation state is something which you call as a reduction. Reduction takes place at cathode. So at cathode, I would say Ag positive aqueous. At cathode, Ag positive aqueous is getting converted into what? Is getting converted into Ag solid. So my dear students, this is how you have represented this particular cell. Point number 1. Point number 2. Point number 2. What are we supposed to calculate the next? We are supposed to calculate EMF of the cell. My dear students, how do we calculate EMF of the cell? We use the Nernst equation for that. You know your E cell is nothing but E naught cell minus 0.0591 divided by N, and it's going to be log of QC, right? This is the Nernst equation which we shall be using. As per the question, E naught cell is given to me. E naught cell is given to me. Now, what is the value of N for the reaction? What is the value of N for the reaction? Simple thing. 0 to +2. Increase in the oxidation state means oxidation, loss of electrons. So I would say 1 mole of magnesium is losing 2 moles of electrons. So simply, I got to know the value of N over here, that is 2. I got to know the value of N, that is 2. Now, it is the time to calculate QC, reaction quotient. How do we exactly calculate reaction quotient? For that, look at the products. This product is in aqueous state, so I'll be using concentration of Mg di-positive raised power stoichiometric coefficient, that's 1. This is in solid state, its active mass is unity, I have got nothing to do with it, divided by. This is again in solid state, nothing to do with it, its active mass is unity, and I'll be writing concentration of Ag positive raised power stoichiometric coefficient, that is 2. Now people, all the things are given to us. Mg di-positive concentration, that is 0.13, divided by Ag positive concentration, that is 10 raised power minus 4. 10 raised power minus 4 ka square comes out to be 10 raised power minus 8. So this is the value of QC. Perfect. Now if you look at this particular expression, E naught cell is given to us. N value we got to know. QC we got to know. Just put the values and get the value of EMF of the cell. That is something which you were supposed to calculate. Am I clear with this particular question? Quickly in the chats. And when you solve it, my dear students, at the end you are going to get the answer as 2.96 volts. This is going to be the exact answer of this particular question. Perfect. I am moving on to the next question. The question says, calculate the equilibrium constant for the reaction. We are given with the reaction, we are given with the E naught cell value, and we are supposed to calculate the equilibrium constant. My dear students, you must be knowing about one thing. We have discussed all of this in detail. When the cell is at equilibrium, your E cell becomes 0. Your E cell becomes 0. At the same time, you know, your delta G for the cell, that becomes 0. Right? Delta G for the reaction becomes 0. Perfect. And at equilibrium, QC is replaced by equilibrium constant KEQ. So at equilibrium, how do we write the Nernst equation? The general form of Nernst equation, you know, E cell is equal to E naught cell minus 0.0591 divided by N, and it used to be log of QC. Now, if I write the same equation at equilibrium, your E cell becomes 0, right? You have to replace QC with equilibrium constant. So the new equation at equilibrium becomes E naught cell is equal to 0.0591 divided by N, and it's log of equilibrium constant KEQ. Perfect. What are we supposed to calculate? We are supposed to calculate the equilibrium constant for the reaction. Right? Right, people? We are supposed to calculate equilibrium constant for the reaction. Now, it's done and dusted. Every single parameter is given to us. Have a look properly. As per the question, what is E naught cell? E naught cell is 0.46 is equal to 0.0591. What is the value of N? N value. How many moles of electrons are exchanged in the reaction? See, 1 mole of copper is losing 2 moles of electrons. So N value simply is 2. And it's going to be log of equilibrium constant to the base 10. Perfect. My dear students, when you solve this, I think you are going to get the value over here as log of equilibrium constant to the base 10 is equal to, this will be 15.6 approximately. This will be approximately 15.6. So I would say your equilibrium constant is nothing but it is NT log of 15.6. Do you remember how do we get the NT logs? Do you remember how do we get the antilogs, people? See, 15.6 I'm going to break as 15 plus 0.6, right? 15 plus 0.6. 15 I'm directly going to write as 10 raised power 15 multiplied by. This 0.6 is basically the log of what? It is the log of 4. So 4 into 10 raised power 15 is going to be the value of equilibrium constant for this particular reaction, right? Am I clear with this? Am I clear with this? Yeah, a very simple and basic question again this was. Let's move on to one more question. Look at this particular question, guys. Again, a simple basic question. And these are your NCERT examples as well as the exercise questions first of all. The question says the standard electrode potential for the Daniel cell is 1.1 volt. Calculate the standard Gibbs free energy of the reaction. How do we calculate the standard Gibbs free energy of the reaction? Delta G naught. Delta G naught, you must be knowing, it is minus NF E naught cell, right? Minus NF E naught cell. So my dear students, what is the value of N for the reaction? 1 mole of zinc loses 2 moles of electrons. So N value directly is 2. Faraday's constant is nothing but 96500 coulombs. E naught cell is given to me as per the question, that is 1.1 volt, right? Since I've taken all the parameters as per SI system, so I'll be getting the value of delta G naught as per SI system as well. And the unit of delta G naught as per SI system is nothing but joules. Perfect. If you're supposed to calculate it in kilojoules, then you'll be dividing it with 1000. Then the answer comes in kilojoules as well, depending on what the options are. Simple and basic question again this is, and I'm pretty much sure you're going to kill this sort of a question. Right, people? Is it clear? Is it clear? Is it clear? Quickly. All right. Look at this particular question, guys. The question says, calculate the potential of the hydrogen electrode. Well, they have not clearly mentioned whether they're asking about oxidation potential of hydrogen electrode or reduction potential. They have not clearly mentioned that. They have just asked to calculate potential. Whenever they'll ask the question in this general format, to calculate the potential, understand you have to calculate reduction potential at that time. You have to calculate reduction potential of the hydrogen electrode. So my dear students, you need to calculate the reduction potential of hydrogen electrode in contact with a solution whose pH is 10, right? Whose pH is 10. I hope you remember your hydrogen electrode. Since we are supposed to calculate the reduction potential of hydrogen electrode, so I'll make sure this hydrogen electrode behaves like the cathode, because at cathode only reduction takes place. Perfect. So when hydrogen electrode behaves like the cathode, reduction takes place. The reaction is supposed to be 2 times H positive aqueous plus 2 electrons. It gives what? It gives H2 gas. It gives H2 gas. Perfect. Now, if I ask you how many moles of electrons are exchanged here, you'll say 2 moles of electrons are exchanged. N value is 2. N value here is 2. If N is 2, get the value of QC. QC is going to be simply a partial pressure of H2 gas. Partial pressure of H2 gas raised par stoichiometric coefficient, that's 1, divided by concentration of H positive raised par stoichiometric coefficient, that is 2. Right? My dear students, here in this particular question, partial pressure of H2 is not specified. So I'll be assuming the partial pressure of H2 over here as 1 bar or 1 atm. This is something which I'm assuming. Divided by concentration of H positive raised par 2, or you can say it is concentration of H positive raised par minus 2. Right? This is the value of QC. If this is the value of QC, how do I write the Nernst equation? This is how I'm going to write the Nernst equation. Reduction potential of the half cell, reduction potential of the hydrogen electrode is equal to standard reduction potential of the hydrogen electrode minus 0.0591 divided by N, and it's going to be log of what? Log of QC. Now people, tell me one thing. If you remember, for the hydrogen electrode, SOP as well as SRP, both the things are 0. As per reference, SOP as well as SRP for the hydrogen electrode, that is 0. So I would say your reduction potential of the half cell becomes nothing but minus 0.0591, N value is 2, log of QC. QC is nothing but concentration of H positive raised par minus 2, right? So ERED is equal to minus 0.0591 divided by 2, log of M raised par N is N log M. So minus 2 comes to the front. This is log of H positive concentration. So 2 and 2 gets cancelled out. So I would say ERED is equal to minus 0.0591. What is minus log of H positive? Minus log of H positive is something which you call as pH. Minus log of H positive is something which you call as pH, right? Minus log of H positive is something which you call as pH. My dear students, since in this particular question I have derived this expression, otherwise if you remember, I have given you this particular expression in the marathon itself. In the session itself, I have given you this particular expression. I hope you remember. I hope you remember. But this expression is used when the partial pressure of H2 is kept as 1 bar or 1 atm. Perfect. Now, what is the pH given? pH is given to me as 10. So, I would say reduction potential of the hydrogen electrode will be minus 0.0591 multiplied by 10. So, the value will be minus 0.591 volt. This is going to be the reduction potential of the hydrogen electrode which I was supposed to calculate. Right? Am I clear with this quickly in the chats? Everybody? Perfect. All right. I'm moving on to one more question. Again, the similar sort of question, guys. Again, the similar sort of question. I'll be sharing you the PDF of this particular session on my Telegram, which is Wassim Bhat Chemistry Official. That is my Telegram ID, right? Wassim Bhat Chemistry Official is a Telegram channel wherein I keep on sharing the handwritten PDFs of all these sessions which I take here on this particular channel. Okay? Look at this question, guys. You're given with a cell reaction. What are we supposed to calculate? Calculate the EMF of the cell in which the following reaction is given. And at the same time, in this question, E naught cell value is given to us. Given that E naught is equal to 1.05. Again, a simple question. Since the cell reaction is given to us, if I ask you what would be the reaction quotient expression, QC. QC expression is going to be concentration of nickel dye positive. Concentration of nickel dye positive raised power stoichiometric coefficient 1. This Ag is in solid state, nothing to do with it, divided by. Nickel is in solid state, nothing to do with it. This is going to be concentration of Ag positive raised power stoichiometric coefficient 2. What is the concentration of nickel dye positive? 0.16. And this is 0.002, which means 2 into 10 raised power minus 3, which comes out to be 4 into 10 raised power minus 6, because there's a square here. So QC, you can find easily from here. Now N value, have a look. Nickel here is in zero oxidation state, so 0 to plus 2. 0 to plus 2, increase means oxidation. Increase means oxidation, loss of electrons. So I would say 1 mole of nickel is losing 2 moles of electrons. So N value here is 2. QC you got, N you got. E naught cell as per the question is given to me as 1.05 volts. Now simply you just have to use an Nernst equation. That's all, right? So I would say your E cell is nothing but it is E naught cell minus 0.0591 divided by N, and it's going to be log of QC, my dear students. E naught cell as per the question is given. N value we got, QC we got, put the values and get the answer exactly. That's something which you were supposed to get. Done and dusted. Done and dusted, people. Right? Perfect. Perfect, guys. All right, this is one more simple question which I believe you can easily solve. The question is the conductivity of these many molar acetic acid is this much. Calculate its dissociation constant if molar conductance for acetic acid at infinite dilution is 90.5 Simon centimeter square per mole. Yeah. The questions asks, what are we supposed to calculate? Dissociation constant. First of all, people, if you see carefully, we are given with the conductivity of the acetic acid solution. Kappa value is given. Kappa is given to me as 4.95 into 10 raised power minus 5 Simon centimeter inverse. This is the conductivity that's given to me, right? If conductivity is given to me, concentration or molarity of CH3COH solution is also given to me as 0.001028 molar. This is the concentration of acetic acid solution that's given to me. At the same time, molar conductivity at infinite dilution of CH3COH is also given to me as 390.5 centimeter square per mole, right? These are the parameters which are given to me. Okay. Now, if these are the parameters which are given to me, can I calculate molar conductance of this CH3COH at a given concentration C? How do we calculate molar conductance? You should remember it. And I'm pretty much sure you'll be remembering this. Lambda is equal to kappa multiplied by 1000 divided by molarity. If you want to calculate lambda m in Simon centimeter square per mole. This is the expression. Now, my dear students, kappa value is given to me. Molarity of the solution is also given to me. So you can easily calculate molar conductance of the electrolyte at a given concentration. So this is done. This is done. You have calculated molar conductance of the electrolyte at the given concentration. At the given concentration. If you have calculated lambda MC, then if you remember alpha, how do we calculate alpha? Degree of dissociation of the weak electrolyte. You should remember it. It is molar conductance of the electrolyte at a given concentration divided by molar conductance of the electrolyte at infinite dilution. My dear students, this is something which you have calculated from here. Divide by lambda naught M is given to me as per the question. So you can easily calculate alpha from here. You can easily calculate alpha. And as far as I remember the values, I think alpha value you would get as 0.1 approximately. This is the value of alpha when you put the values. This would be the value of alpha. Since you got the value of alpha, what am I supposed to calculate? Dissociation constant of acetic acid. Dissociation constant of acetic acid. Tell me one thing. How the acetic acid would undergo dissociation? How the acetic acid would undergo dissociation? It would have undergone dissociation in this manner. CH3CO negative aqueous. And with this, it's going to be H positive aqueous. You know, its concentration initially is C, which is given to me. This would be 0. This would be 0. Let's say degree of dissociation is alpha. So this is at equilibrium. This is supposed to be C minus C alpha. This is going to be C alpha. This is going to be C alpha. Now, my dear students, if you want to write the expression for dissociation constant of this weak acid, how do you write the expression? C alpha square divided by 1 minus alpha. Now, people, all the things we already have. Concentration. C is the concentration of the given electrolyte. That's given to me C. Alpha we have calculated. Alpha go square divided by 1 minus alpha. Put the values and get the value of Ka from here, which is something I was supposed to calculate. Right? These sort of questions I have already shown you in the lecture itself, guys. And you should be in a position to solve this question on your own without my help now. Okay? Perfect. And when you finally solve the question, the value of the Ka value is going to be 1.78 into 10 raised power minus 5. Okay? Look at this particular question. Check the question. Sir, in this question, alpha is negligible. What is the value of alpha which we got? Alpha value we got as 0.1. It is not negligible. If the value of alpha was less than 0.05, if the value of alpha was coming out to be less than 0.05, then you could have neglected alpha in comparison to 1. But here, you cannot neglect alpha in comparison to 1. You have to keep alpha here in the denominator. Okay? Right, people? Someone is asking, can this type of complicated question ask in NEET? This is not complicated. This is easy. If you have watched the lecture. In the lecture, I have shown you these sort of questions in detail. And this is your NCERT example question, so it can be asked. Right? So it can be asked. That's why I keep on telling you, do not take the lectures lightly. If you would have watched the lecture, this question wouldn't have been tough for you. It would have been the easiest question of all. All right, look at this one. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at cathode? You are doing the electrolysis of copper sulfate. When we do the electrolysis of copper sulfate at cathode, what happens? Reduction. At cathode, copper dye positive gains 2 electrons, gets converted into copper solid, and this copper solid is deposited at cathode. This copper solid is deposited at cathode. Now, my dear students, if you look at all the things carefully, first of all, what am I supposed to calculate? What mass of copper is deposited? If you remember your Faraday's first law of electrolysis, mass of substance deposited, mass of copper deposited will be equal to equivalent mass of copper multiplied by current multiplied by time divided by divided by 96500. Divided by 96500. This is the expression which we use. I hope you remember. Now, my dear students, what would be the equivalent mass of copper? First of all, tell me, what is the n factor of copper here? N factor of copper means number of moles of electrons exchanged divided by stoichiometric coefficient. So 2 divided by 1 is 2. Equivalent mass of copper is molar mass of copper in grams divided by n factor, that's 2. In the denominator, you have got 96500. Current is 1.5 amperes, which goes into the solution. In how much time? 10 minutes. So convert this into seconds, right? Solve this expression and get the value in grams. This is going to be the mass of copper deposited when we do the electrolysis of copper sulfate by the passage of 1.5 amperes of current for exactly 10 minutes. Right? Right, people? Yes, M square, you can consult them. Yes. All right. moving on to one more. Look at this particular question, guys. Again, a simple and basic question. You should kill it. These are basic questions which I've come up with in the beginning, right? Slowly the level is going to increase. How much charge is required for the following reduction? How much charge is required for the reduction of 1 mole of Al tripositive? My dear students, Al tripositive, when it undergoes reduction, that means it will be gaining 3 electrons. It would be getting converted into aluminum solid. Perfect. So, as per this particular balanced chemical equation, I can say for the reduction of 1 mole of Al tripositive, 3 moles of electrons are used. For the reduction of 1 mole of Al tripositive, for the reduction of 1 mole of Al tripositive, 3 moles of electrons are used. Perfect. The charge present on 1 mole of electron is equal to 1 farad. So the charge present on 3 moles of electrons would be 3 farad, right? So this much charge is required for the reduction of 1 mole of Al tripositive into aluminium, right? Or you can just write the Faraday's constant exactly, which is 96500, and the answer is going to be in coulombs. Perfect. Done and dusted. 1 mole of copper dipositive into copper. This is something which you can easily solve now. This is something which you can easily solve. If you want to do the reduction of 1 mole of copper dipositive would be gaining 2 electrons, getting converted into copper solid. So I would simply say for the reduction of 1 mole copper dipositive, for the reduction of 1 mole copper dipositive, 2 moles of electrons are used. 2 mole electron means 2 farad charge. 2 farad charge means 2 multiplied by 96500 coulombs. Right? And similarly, you can do this as well. Similarly, you can do MnO4 negative, you have to convert into what? MnO4 negative, you have to convert into Mn di positive. My dear students, if you look carefully, the oxidation state of manganese here is +7. Perfect? +7. +7 to +2. +7 to +2. Decrease in the oxidation state means reduction. So I would say this MnO4 negative would be gaining 5 electrons and getting converted into Mn di positive. Perfect? So I can say when we do the reduction of 1 mole of MnO4 negative, how many moles of electrons are required? For the reduction of 1 mole of MnO4 negative into Mn di positive, I would say 5 mole electrons are used. 5 mole electrons means 5 farad charge. 5 farad charge means 5 into 96500 coulombs. I believe this is super clear to everyone. Yes, Maran, you can meet me. You can just ping me on my Telegram after the session ends. I'll let you know where I can meet you. Okay? Perfect. Moving on. Moving on, guys. Similar sort of question. How much electricity in terms of farads is required to produce 20 grams of calcium from molten CaCl2? When you do the electrolysis of molten CaCl2, what is the reaction which takes place at cathode? Calcium dipositive would be getting 2 electrons, getting converted into calcium solid. This is the reaction which would be happening. Perfect. Now, my dear students, how much electricity in farads is required to produce? We have to produce 20 grams of calcium. 20 grams of calcium means how many moles of calcium? Mass of calcium divided by molar mass of calcium. So the value comes out to be 0.5. As per the question, we have to produce 0.5 moles of calcium. Well, as far as this particular reaction is concerned, I can say in order to produce 1 mole calcium, I would say 2 moles of electrons are required. That means 2 farad charge is required. Right? For the reduction, for the deposition of 1 mole calcium, 2 farad of charge is required. But as per the question, do I need to deposit 1 mole of calcium? No, I have to deposit 0.5 moles of calcium. So for the deposition of 0.5 moles of calcium, how much charge is required? 2 multiplied by 0.5. The value comes out to be 1 farad. So 1 farad of charge is required for the deposition of 20 grams of calcium over here. Okay? I believe the second question you can easily solve on your own. Right? The second question you can easily solve, I believe. In the second question, what should be the reaction? We need to deposit aluminium from molten Al2O3. So reaction has to be what? Al tripositive plus 3 electrons gives aluminium solid. Right? Gives aluminium solid. Perfect? Who is saying 4 farad? It's 1 farad, not 4 farad, guys. It's 1 farad. Do not make these silly mistakes. They are going to kill you. Okay? Alright, I believe this sort of a question you can easily solve. Okay? Right? So, we have to deposit 40 grams of aluminium. 40 grams of aluminium means how many moles of aluminium? Mass of aluminium divided by molar mass of aluminium. These many moles of aluminum we have to deposit. For the deposition of 1 mole of aluminum, how much charge is required? 3 farad. So for the deposition of 40 divided by 27 moles of aluminum, how much charge is required? 3 multiplied by 40 divided by 27 farad. Done and dusted. Yeah? Perfect. Moving on. Again, a similar sort of question. You can easily solve this. A solution of NiNO3 twice is electrolyzed between platinum electrodes using a current of 5 amperes for 20 minutes. What mass of nickel is deposited at cathode? Similar sort of question. Similar sort of question, guys. Similar sort of question. See, for the deposition of nickel, what has to be the reaction? The reaction is going to be nickel dye positive in the solution is going to gain 2 electrons, get converted into nickel, and this particular reaction would be taking place at cathode. Perfect, because at cathode only reduction takes place. So first of all, if I ask you what is the N factor of this nickel, N factor of this nickel is equal to moles of electrons exchanged divided by stoichiometric coefficient. So 2 by 1 is equal to 2. This is the N factor of nickel. Now, as per the question, we have to calculate the mass of nickel deposited. Mass of nickel deposited will be equivalent mass of nickel multiplied by I multiplied by T divided by 96500. I think all the parameters are given. Equivalent mass of nickel is equal to molar mass of nickel divided by N factor of nickel. Right? Molar mass of nickel divided by N factor of nickel. Current is given to me as 5 amperes. Time is given to me as 20 minutes multiplied by 60 seconds divided by 96500. This sort of a question we have already solved once. Okay, now it's just the matter of calculation, nothing else. It is just the matter of calculation, nothing else. It is just the matter of calculation, nothing else. Look at this particular question, guys. Given that standard electrode potentials of certain elements are given, arrange these metals in the increasing order of the reducing power. Reducing power, right? You know, a better reducing agent has got more reducing power, right? You know, reducing agent itself undergoes oxidation. Reducing agent itself undergoes oxidation. I would say the one which undergoes oxidation easily, that's the better reducing agent. Now, which can undergo oxidation easily? The one that has got more SOP. The one that has got more SOP. More the SOP, more the tendency to undergo oxidation, better reducing agent, more reducing power. Now, my dear students, what are we given with? What are these values? See, potassium here is in +1, here is 0. +1 to 0, decrease, reduction. So this SRP. +1 to 0, decrease, reduction, SRP. +2 to 0, decrease, reduction, SRP. +2 to 0, decrease, reduction, SRP. So these are all the SRP values which are given to us, right? These are all the SRP values which are given to us. Convert them into SOP. So K gives K positive. This is SOP, which will be +2.93 volts, right? AG gives AG positive. AG gives AG positive. It will be -0.8 volts. Similarly, HG gives HG dye positive. It would be -0.79 volts. Similarly, MG gives MG dye positive. MG gives MG dye positive. It's going to be +2.37 volts, right? Chromium gives chromium tri positive. It's equal to +0.74 volts. Perfect. So these are the SOP values of the elements which are given to me. Yeah. So this is the SOP of potassium. This is the SOP of silver, SOP of mercury, SOP of magnesium, SOP of chromium. So you got the SOPs. Which one has got the least SOP? Or which one has got maximum SOP? Which one has got maximum SOP? Maximum SOP is potassium. So potassium is going to be, potassium will show maximum reducing power. Potassium has got maximum SOP. So potassium will show maximum oxidation, maximum reducing power. Right? Arrange the following in the order of increasing. Okay. So potassium. Potassium will have maximum reducing power. Followed by magnesium. Followed by which value comes the next? Followed by chromium. Right? Which value comes the next? Which value comes the next? That's going to be mercury. Which is next? That is silver. Perfect. That's silver. I believe this is clear. This is going to be the increasing order of what? Reducing power of these elements which were given to me. Perfect. Perfect, guys. I believe this sort of a question you can easily solve from now on. Okay, a simple basic question. What would be its answer? The conductivity of a 0.2 molar solution of KCl is given. We need to calculate molar conductivity. Lambda m is equal to kappa multiplied by 1000 divided by molarity. If you are supposed to calculate lambda m in Siemens centimeter square per mole. Perfect. Now, as per the question, what is the value of kappa? Kappa value is 0.0248 multiplied by what? 1000. Molarity of the solution is 0.2. Solve it and get the answer. That's it. Yeah? Simple basic question again. All right. All right, people. Okay, the cell reaction is represented by. The cell reaction is represented by. Tell me the answer. Tell me the answer, guys. Which one is the correct representation of this particular cell reaction? Correct representation of the following cell. See, guys, again a simple question this is. Copper here is in zero oxidation state, silver in +1, copper +2, silver 0. See, guys, 0 to +2, increase in the oxidation state means oxidation. Oxidation takes place at anode, right? So if this is the salt bridge, on the left side, I'll write anode, and at anode, your copper solid is getting converted into copper dipositive aqueous. This is something which happens at anode. On the right side, you'll be writing cathode. At cathode, reduction takes place, and Ag positive gets converted into what? Ag positive at cathode is getting converted into Ag solid. So this is how you have represent the cell. Is there anyone like this? Copper solid gives copper dipositive, Ag positive gives Ag solid. So it's the first option only, right? First option only is the correct one. First option only is the correct one. Perfect, yes. Look at this particular question. The question is, you are given with the cell. Which of the following is correct? Copper is a reducing agent. See, copper is getting converted into copper dipositive anode, 0 to +2. Increase means oxidation. The one that undergoes oxidation is going to be the reducing agent. So copper here is a reducing agent. Yes, copper is a reducing agent. So 1 is correct. 1 is correct. So this cannot be correct. This can be correct. This can be correct. This cannot be correct. Now, the second thing. Overall cell reaction is this. Let's get to know what is the overall cell reaction. Let's get to know what is the overall cell reaction. First of all, if you look at anode, at anode, copper is getting converted into copper dipositive. At anode, oxidation takes place, and copper is getting converted into copper dipositive, and with this you'll be writing 2 electrons. This is the reaction taking place at anode. Similarly, if I ask you what is the reaction taking place at cathode reduction takes place. Ag positive gives Ag. So the reaction has to be Ag positive aqueous plus 1 electron gives Ag solid. Now, my dear students, if I ask you whether the electrons are balanced in both the reactions or not, the electrons are not at all balanced. The electrons are not at all balanced. So I need to balance the electrons first. So I'll just multiply this particular reaction by number 2. This becomes 2 times, this becomes 2 times, this becomes 2 times. Now the electrons are balanced, so you can directly add these 2 reactions. When you add these reactions, you'll be getting copper solid plus 2 times Ag positive aqueous. It gives what? It gives copper dipositive aqueous plus 2 times Ag solid. This is the net reaction. This is the net reaction. Is the net reaction given in the same format? Copper solid plus 2 times Ag positive gives copper dipositive plus 2 times Ag solid. Yes, this one is also correct. Option 2 is also correct. Option 2 is also correct. So directly, D is the one that's going to be the correct answer of the question. Perfect. Perfect, guys. Look at the third option. Copper is cathode. Since copper is on the left side of the salt bridge, on the left side we always write anode. So copper is anode and silver is a cathode. But here they have given the reverse form. I believe I'm clear with this. All right. All right, guys. What do you think about this particular question? What do you think about this particular question? My dear students, look carefully. Li positive gives Li. Li positive gives Li. Is it SOP or SRP? Check it out. +1 to 0. +1. This is +1 here. This is 0. +1 to 0. Decrease. Decrease means reduction. So this SRP. I'm giving the SRP. I'm giving the SRP of all of them. So these are basically the SRP values. These are the values of SRP. I have to check which of the following is the strongest oxidizing agent. My dear students, oxidizing agent itself undergoes reduction. The one that can undergo reduction easily is the better oxidizing agent. Which can undergo reduction? The one that has got more SRP. The one that has got more SRP will undergo reduction easily, better oxidizing agent. Now compare these SRP values. Which one has got maximum SRP value? Maximum SRP value I can see here is minus 2.37. It's maximum among all, and it's for magnesium dipositive. So magnesium dipositive is the better oxidizing agent over here. Done? Done, people? Done with this? Okay. One more simple question. My dear students, do you remember your E naught cell? E naught cell used to be equal to E naught of cathode minus E naught of anode. And if you remember in this particular result, this used to be SRP of cathode. This used to be SRP of cathode. This used to be SRP of anode. Perfect. So one of the options is E naught cell is nothing but SRP of cathode minus SRP of anode. This is one of the equations with the help of which you can calculate E naught cell. Now, can you convert this into different formats? You can convert this into different formats. This is SRP of cathode. Instead of SRP of cathode, I can write minus SOP of cathode. Right? Instead of SRP of anode, I can write minus times SOP of anode. Right? Minus becomes plus. So, it becomes SOP of anode minus SOP of cathode. This is equation 1, this is equation 2. Since here both are in SRPs, here both are in SOPs. Now, there can be one more result where one is in SOP, one is in SRP. One is in SRP, one is in SOP. You can do the conversion easily. Right? You can do the conversion easily. Perfect. Right, guys? See, this is one equation to calculate E naught cell. This is one more equation. You can make few more equations. For example, SRP of cathode I'm writing as such. SRP of cathode I'm writing as such. Instead of SRP of anode, I'm writing minus times SOP of anode. Minus becomes plus. So SOP of anode. This becomes one more result. So you can make one more like this. Yeah? Perfect. Look at this simple question. Look at this simple question. Standard oxidation potential values are given to us. Calculate the EMF of the cell. See guys, the cell reaction is given to me. Cell reaction is given to me. Zinc plus Fe di positive. It gives zinc di positive plus iron. If you ask me carefully, what is the oxidation state of zinc here? 0. Iron plus 2. Zinc plus 2. This iron 0. So I would say 0 to plus 2. Increase. Increase means oxidation. Oxidation takes place at anode. So zinc is behaving as anode. So automatically this becomes your cathode. If you identified your anode and cathode, you can easily calculate E naught cell. E naught cell is nothing but E naught cathode minus E naught anode. Right? What is E naught cathode? This is SRP of cathode. What is E naught anode? This is SRP of anode. Okay? SRP of cathode, SRP of anode. Cathode is iron. Cathode is iron. This is the SOP of iron. What do I need? I need SRP. SRP would be minus 0.41. Minus SRP of anode. What is anode? Anode here is zinc. But this is SOP of zinc. I need SRP of zinc. So minus 0.76. The value overall comes out to be 0.35 volts. So this is going to be the E naught cell. Clear? Clear, guys? Even this is a simple question which I believe you can easily solve. Look at this one. As far as this particular question is concerned, calculate the oxidation potential of the following half cell. I'm given with the half cell. I'm given with the electrode. I need to calculate its oxidation potential. My dear students, in order to calculate oxidation potential of this half cell, I'll make sure that this electrode behaves like your anode, because at anode oxidation takes place, right? See, iron here is in 0 oxidation state, here is in plus 2. So what would be the reaction? What would be the oxidation reaction? Oxidation reaction would be Fe solid getting converted into Fe di positive aqueous, and with this you'll be writing 2 electrons. This is going to be the reaction. If this is the reaction, what is the value of N? N value here is 2. Now get the QC value. QC is going to be concentration of Fe di positive raised per stoichiometric coefficient. What is the concentration of Fe di positive here? 0.1. So 10 raised per minus 1. This is the QC. If you got the N value, if you got the QC value, you can use the Nernst equation. oxidation potential of the half cell is equal to E naught OX minus 0.0591 divided by N, and it's going to be log of QC. It's going to be log of QC, right? So people, what is E naught OX? This is SOP. What is the value of SOP? Plus 2 to 0. Plus 2 to 0, decrease, reduction. So this SRP, what do I need? I need SOP. So reverse the sign. 0.44 minus 0.0591 divided by, what is the value of N? N value here is 2, log of QC. What is the QC value? 10 raised per minus 1. Solve this equation and get the answer. Done? Done, people? Perfect. Let's move on to one more. 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 Look at this particular question. Look at this particular question, guys. This might be a bit lengthy question. Okay. It might be a bit lengthy when it comes to calculation. Let's have a look. If you see, we are given the cell. We are given the complete cell. Okay. E cell is given. M di positive divided by M plus 4 concentration is equal to 10 raised per X. What are we supposed to calculate? The value of X. X value we are supposed to calculate. Okay. See, guys. First of all, if you see, this is the salt bridge. On the left side of the salt bridge, we write anode. On the left side of the salt bridge, we write anode. At anode, oxidation takes place. H2 is getting converted into H positive. So reaction has to be H2 gas. H2 gas is getting converted into 2 times H positive aqueous plus how many electrons? Plus 2 electrons. This is the reaction at anode. Similarly, what would be the reaction at cathode? At cathode, M plus 4 is getting converted into M di positive. So what would be the reaction? The reaction would be M plus 4 aqueous plus 2 electrons. It would be getting converted into M di positive aqueous. This is the reaction at cathode. You got reaction at anode, you got reaction at cathode. If I ask you whether the electrons are balanced or not, yes, the electrons are balanced. And if the electrons are balanced, you can directly add these two reactions. When you add these two reactions, my net reaction is going to be H2 gas plus M plus 4 aqueous. It gives what? It gives 2 times H positive aqueous. And with this, you'll be writing M di positive aqueous. M di positive aqueous. This is my net reaction, people. If this is my net reaction, can't we get the QC value? Absolutely. QC value is going to be concentration of H positive raised per stoichiometric coefficient multiplied by concentration of M di positive raised per stoichiometric coefficient divided by, this is partial pressure of H2 gas raised per stoichiometric coefficient multiplied by concentration of M plus 4 raised per stoichiometric coefficient. Now tell me, H positive concentration as per the question is given to me as 1 molar. This is 1. M di positive concentration I'm writing as such divided by partial pressure of H2 is given to me as 1 bar. So this is 1 also divided by, this is M plus 4 concentration raised per 1. Perfect. And this M di positive divided by M plus 4. M di positive divided by M plus 4. This as per the question is given to me as 10 raised per X. It is given to me as 10 raised to the power X. Well, people, now what is next? E naught cell. E naught cell is going to be nothing but E naught cathode minus E naught anode. The cathode here is this particular electrode. What do I need? I need SRP of cathode. SRP of cathode minus SRP of anode. SRP of cathode plus 4 to plus 2, decrease in the oxidation state, reduction. So this is SRP of cathode, 0.15 minus SRP of anode. Anode is your hydrogen electrode. SOP as well as SRP of hydrogen is 0. So E naught cell is nothing but 0.15 volts. This is E naught cell. If you got E naught cell, if you got QC, you got N value also. You got N value also. How many moles of electrons got exchanged? 2. You got N value also. Now you can easily write Nernst equation. E cell is equal to E naught cell minus 0.0591 divided by N, and it's log of QC. And it's log of QC. Now, as per the question, my dear students, as per the question, if you see carefully, E cell is given to me as per the question. E cell is given to me. E naught cell we have calculated. N value we have calculated. And your QC is nothing but, your QC is 10 raised per X. Your QC is 10 raised per X. By solving this equation, can't we get the value of X here? Easily we can calculate. Right? Now, it is just the matter of calculation from here. It is just the matter of calculation from here, nothing else. Yeah? Perfect, guys? Okay, I'm moving on to one more then. I am moving on to one more then. This is again a simple question, guys. A reaction is given. A reaction is given. E naught values are given. Some parameters also given. What are we supposed to calculate? The Gibbs free energy in joules. When concentration is 1 molar, temperature is 298. That means we have to calculate delta G under standard conditions, right? We have to calculate delta G under standard conditions. So delta G naught technically we have to calculate. And delta G naught is nothing but minus N of E naught cell, right? What is the N value for the reaction? How many moles of electrons are exchanged? 2. Faraday's constant. You know already 96500. E naught cell is going to be E naught cathode minus E naught anode. See, copper here is anode, tin is your cathode. So E naught cell is nothing but it is E naught cathode minus E naught anode, right? So it's going to be minus 2 multiplied by 96500. E naught cathode, SRP of cathode, SRP of tin, SRP of tin. This is the SRP of tin, which is minus 0.16, minus SRP of anode, SRP of copper. SRP of copper is given to me as 0.34. Perfect. Solve the equation. Get the answer in joules. That's it. So delta G naught, we are done and dusted. Yeah? Perfect. Moving on to one more question. Moving on to one more type of question. The question is copper dye positive plus 1 electron gives copper positive. And at the same time, copper positive plus 1 electron gives copper solid. Their E naught values are given. This is 0.15 volts and this is 0.5 volts. What are we supposed to calculate? We are supposed to calculate E naught of copper dye positive gives copper. So we are supposed to calculate E naught of copper dye positive gives copper. So for this particular reaction, we are supposed to calculate E. We are supposed to calculate E value for this reaction. We are supposed to calculate E value for this particular reaction. How do we do it? We have seen these sort of questions also. Perfect. We have seen these sort of questions. My dear students, calling this is equation number 1, calling this equation 2, calling this equation 3. How do we get the third equation out of first two equations? How do we get it? If I add 1 and 2, this copper positive cancels. This becomes copper dye positive, 1 plus 1, 2 electrons. Copper dye positive plus 2 electrons gives copper. Copper dye positive plus 2 electrons gives copper. So can I say third equation I'm getting when I'm adding 1 and 2? When I'm adding 1 and 2? Yes, third equation I'm getting 1 when I'm adding 1 and 2. But if you think you're going to solve the equation like this, E3 is equal to E1 plus E2. No, this is not going to be the answer. Because you know, EMF is the intensive property. You cannot add or subtract EMF directly, right? You are going to solve this question in terms of delta G, my dear students. So, you are going to write, instead of 3, you will be writing delta G3 is equal delta G1 plus delta G2. Why? Because Gibbs free energy is the extensive property. You can add or subtract the extensive properties, whereas you cannot add or subtract the intensive properties. Instead of delta G3, you can write minus N3 FE3 is equal delta G1 minus N1 FE1, delta G2 minus N2 FE2. So F everywhere cancels out. So I would say your E3 comes out to be equal to N1 E1 plus N2 E2 divided by what? Divided by N3. Now as per the question, what is the value of N1? N1 value is 1. N2 values 1. N3 values 2. So N1, N2, N3 we have. E1, E2 is given to me. Just put the values and get the value of E3 from here, which is something I was supposed to calculate. Again, a simple basic question which I believe you can easily solve, guys. What happened to the screen? Why the slide is not changing here? Okay. All right. Look at this particular question. Look at this particular question. What do you think about this? As far as this question is concerned, Ksp of AlOH whole thrice is given. E naught of Al tripositive gives Al is given. Reduction potential of this electrode couple at pH equal to 12. Okay, we are supposed to calculate reduction potential. Understand? It's a good question. We are supposed to calculate reduction potential of this particular half cell, this particular electrode. In order to calculate reduction potential, a reduction should happen. Reaction is supposed to be Al tripositive plus 3 electrons gives what? Gives Al. This is the reaction first of all, which you have mentioned. If this is the reaction, what is the value of N? N value over here is equal to 3. 3 moles of electrons are exchanged. What about the QC value? QC is going to be 1 divided by concentration of Al tripositive raised power 1. But my dear students, is anywhere Al tripositive concentration given to us? No. Al tripositive concentration is not given to us. So how do I calculate Al tripositive concentration? Look carefully. As far as the question is concerned, pH is given to me as 12. If pH is 12 at 25 degrees centigrade, therefore pOH will be 14 minus 12, that's 2. So I can get OH negative concentration from here, which is 10 raised power minus 2 molar. I got OH negative concentration. Yeah. Since I got OH negative, but I do not need OH negative here. But people, if you look carefully, we are given with the Ksp of AlOH whole thrice. First of all, tell me how this AlOH whole thrice will undergo dissociation. It will be Al tripositive aqueous, 3 times OH negative aqueous. So if you want to write its Ksp expression is going to be concentration of Al tripositive raised power 1, concentration of OH negative raised power 3. Now Ksp as per the question is given to me, 10 raised power minus 36 is equal to Al tripositive concentration I want to calculate. OH negative concentration is 10 raised power minus 2. Raised power 3 becomes 10 raised power minus 6. So Al tripositive concentration came out to be 10 raised power minus 30 molar. If you got Al tripositive concentration, so QC is going to be 1 divided by 10 raised power minus 30. So it comes out to be 10 raised power 30. This is QC. This is your QC, guys. You got QC, you got N, right? E naught values are given to us as well. What am I supposed to calculate? I need to calculate the reduction potential. Use the Nernst equation and we are done. As per Nernst equation, reduction potential of the half cell is equal to standard reduction potential of the half cell minus 0.0591 divided by N, and it's log of what? Log of QC. As per the question, standard reduction potential of the half cell is given to me. Al tripositive to Al, yes, plus 3 to 0, decrease reduction. So this SRP, so it's given to me minus 1.66. This is given to me as minus 1.66. N value we have already calculated. How much? N value is 3. N value is 3. QC we have calculated 10 raised power 30. Put the values and get the value of reduction potential of the half cell, which I was supposed to calculate. Yes. With this way, people, you can easily solve this survey question if it comes. All right. Let's have a look on few more questions. Let's have a look on few more questions. Just a second. Let's have a look on few more questions. Look at this one, guys. Look at this one. Consider the following cell reaction. We are given the cell reaction. Okay. My dear students, the cell reaction that's given to us, if E cell is equal to E naught cell at 25 degrees centigrade, Fe dipositive concentration is given, partial pressure of O2 is given, pH is equal to X, we have to calculate X. Okay. How do we solve this? What is the procedure of solving this question? If you look at the cell reaction, can we calculate the reaction quotient? Yes. Start with the product. Concentration of Fe dipositive raised power 2. What is in liquid state? Nothing to do with this. Solid, nothing to do with this. Partial pressure of O2 raised power 1 multiplied by concentration of H positive raised power 4. Okay. Now, my dear students, as per the question, what is the concentration of Fe dipositive given? Concentration of Fe dipositive is given to be as 10 raised power minus 3. 10 raised power minus 3 ka square is 10 raised power minus 6. What is the partial pressure of O2? Partial pressure of O2 is 10 raised power minus 2. 10 raised power minus 2 multiplied by concentration of H positive raised power 4. Okay. As per the question, what is the pH? pH is given to me as X. If pH is X, that means concentration of H positive over here is going to be 10 raised power minus X molar. Okay. So this is going to be 10 raised power minus 6 divided by 10 raised power minus 2. Concentration of H positive is 10 raised power minus X raised power 4, which is 10 raised power minus 4X. So it becomes 10 raised power minus 4 divided by 10 raised power minus 4x. This is the value of QC. This is the value of QC. Now, as per the question, if E cell is equal to E naught cell, you know your E cell expression. E cell expression is nothing but E naught cell minus 0.0591 divided by n log of QC. Now, you tell me one thing. When can be E cell and E naught cell equal? E cell and E naught cell can be only equal if this term is 0. When can this term is 0? This term can only become 0 if QC is 1, because log of 1 then becomes 0. If QC is 1, then log of 1 is 0. This term is 0. At that point itself, E cell would be equal to E naught cell. So E cell is only equal to E naught cell if QC is equal to 1. If QC is equal to 1. What is QC? QC is 10 raised power minus 4 divided by 10 raised power minus 4x. This has to be equal to 1. So 10 raised power minus 4 has to be equal to 10 raised power minus 4x, which is telling you nothing but x has to be 1. Right? Clear, people? I believe this is also clear to everyone. I believe this is clear to everyone. Okay? And guys, there are some 10 more questions. There are some 10 more questions which I am not solving, which I am giving you as the homework. And you are going to find these questions on my Telegram. The questions are already there. Some 10 questions for your homework from the same chapter, Electrochemistry, right? You can go to your Telegram channel, which is Wassim Bhat Chemistry Official, wherein I shall be the PDF of this particular session right after the session ends. And you are going to solve those 10 homework questions by your own. And I believe you can easily solve them. Okay? Perfect. So with this, I'm taking a leave. With this, people, I'm going to take a leave. And there is a super surprise coming up for all the students, the ones who were waiting for the NEET 2025 fast track batch in English by your Unacademy NEET English team. You are going to get the surprise in coming 2 to 3 days. Okay? Perfect. Sir, subas gese syllabus khatam. Subas ya kvel ket gese mostly syllabus khatam. Yes? Perfect, guys. Chalo, I'll see you guys tomorrow or day after tomorrow, wherein you are going to get a super surprise for the NEET 2025. With this, I'm taking a leave. You take care. God bless you all.